Hi guys, let's look at this review. I'm going to work out the problems for you guys, and hopefully we're all gonna feel pretty good about this quiz. So, here we go. On these problems, I see a bunch of right triangles. I'm gonna have to decide how I'm gonna solve them. So, on this first one, I see that I have a right triangle and I'm given two sides, the legs, and I'm looking for the hypotenuse, which is right there. So I'll use the Pythagorean theorem. These problems are asking you to explain your choice on each one. I want you guys to actually write out an explanation, okay? So here's an example. I just verbally kind of said it. My choice to use the Pythagorean theorem to solve for the hypotenuse is explained because I was given a right triangle and knew the length of two legs. So we want to use the vocab. We want to be kind of full sentence using all of our language skills. Here we go. Pythagorean theorem. First step, I want to see you guys write the formula. C squared equals A squared plus B squared. Then we plug in the values. X squared equals 9 squared plus 12 squared. And then I'm going to use the calculator to get that 81 plus 144 equals x squared. And then 81 and 144 is going to be 225. So when I square root both sides, I get that x equals 15. Okay, number 2. I have a right triangle. I am only given one side. Okay, so Pythagorean theorem is not going to cut it. I notice that I've got a 60-degree angle. That makes this a 30, 60, 90 triangle. So I will use the 30, 60, 90 triangle theorem to solve this. Now for these, we must take the short leg, which is across the 30. We must always begin with that. And then we can double it to get the hypotenuse. So 2 rad 3 doubled is going to be 4 rad 3. And then we can multiply. Again, we go back to the 30. We use the 30 side to get everything else. We use the short leg to get everything else. I multiply this by rad 3 to get the long leg. So 2 rad 3 times rad 3 will become 2 times 3. Here, let me write it for you guys here. 2 rad 3 times rad 3. It becomes 2 times 3, which is 6. On number 3, again, I have a right triangle, and I know two sides. They are both the legs. So I will circle the hypotenuse and go to the Pythagorean theorem. X squared equals 3 squared plus 7 squared. X squared equals 9 plus 49. X squared equals 58. So then x equals the square root of 58. And now 58, just to double check on that guy, if I divide it by 2, I get 29. Factor tree on 58 is 2 and 29. No one's getting out of jail with that. So it stays square root of 58. On number 4, I know one side of a right triangle. Can't use Pythagorean theorem. But I notice that it's a 45-45, so I can use the 45-45-90 theorem. Here, the hypotenuse is 7. Well, I know that the hypotenuse is typically something radical 2, k rad 2. So I solve this. I will divide both sides by radical 2. So I get 7 divided by radical 2. I can't have 7 over rad 2 because I can't have a radical in the denominator. So I'll multiply top and bottom by rad 2 to get 7 rad 2 over 2. That's this side and this side. Okay. And now on number 5, I've got a right triangle. I know they've drawn the altitude for me, and we're dealing with that. So that's going to be the similar right triangles method, okay? Because you've got a right triangle with an altitude drawn. So on this guy, I can separate these triangles. Where will I have room to do that? Let's go here. I can separate the triangles, so let's go like this. And then the first one, I'm just going to label up as is. So this is an X. And then I have 6 and 3. That's 9 right there. Then I've got, let's go labeling the right angles. And then let's go labeling these guys. The blues are here. And on this triangle, it's here. Let's go black, because I already used green. That angle is there and there. So here and here. Okay. Now I will go and label the rest. So 6 is here across the double angle on the middle guy. This is 6. And then the 3 is across the blue angle on the little guy here. And then X is also across, it's the hypotenuse of the middle guy here. So there I am. Okay, I can say 6 over X equals X over 9. Cross multiply, X squared equals 6 times 9 is 54. And that breaks into 6 and 9. 9 is 3 and 3. 3 and 2. These guys break out. These guys don't. So X equals 3 rad 6. Okay. On this one, we have 4 rad 3 and 4 rad 3. It's a right triangle, and I know these two sides. So I have a choice. I can do Pythagorean theorem. Or I might notice if 4 rad 3 and 4 rad 3 mean that these two sides are the same. That means that these two angles must be the same, which means that they can only be 45 degrees. So I can also use 45, 45, 90 to do this one. My choice, okay? I like the 45, 45, 90 triangle. So all I got to do is take my leg of 4 rad 3 and multiply it by rad 2 to get the hypotenuse. This becomes 4 rad 6. Over here, again, right triangle, I know 2 of the sides, so c squared equals a squared plus b squared. The hypotenuse I got to circle is 21, so 21 squared equals x squared plus 8 squared. And then 21 squared is 441. And x squared plus 64, then subtract that 64, 377 equals x squared, and then I don't know what goes into 377. 3 doesn't, 5 doesn't, does any random number like 13 go? Yeah, 13 goes, but who cares, because 13 times 29 is 377, and nobody's breaking out of that jail. So here, x equals square root of 377. On number 8, I know the long leg of a 30, 60, 90 triangle is 8. I have to know the short leg first, and that's right here, the 30. So from the long leg to the short leg, I have to divide by rad 3. Multiply top and bottom by rad 3. 8 rad 3 over 3 is right here. Okay. Then, to get the hypotenuse, I have to multiply this by 2. From the short leg to the hypotenuse is just times 2. So it becomes 16 rad 3 over 3. On number 9, we can separate these triangles. We can also use the rainbow method if you watched the video and you saw it. So the rainbow method would say 13 over x equals x over 4. But to separate the triangles, because that's the way we've kind of been working on it, it's going to be on the medium triangle. Let's see what we got here. If this is the blue, this is the blue. And if this is the green, this is the green. And so we have that 13 is across the green on the medium, that 4 is across the blue on the small one, x is across the blue on the medium, and x is across the green on the small one. So we get the same 13 over x equals x over 4. When we cross multiply, we get x squared equals 13 times 4. Again, you guys, I do this sometimes. I don't see the point in multiplying these out because now I'm just going to square root, and it's easier to square root this because 4 is just 2 and 2. I have a pair, so x equals 2 square root of 13. Here's a good one. Number 10, we have two triangles and they are joined. So we want to find x. We have a 45, 45, 90 when we know a leg. We got to bring this information over here somehow. So to get the hypotenuse of the 45, 45, 90, I have to multiply this by rad 2. So I take the 9 rad 3 and I multiply it by radical 2. And I get 9 rad 6 over here. Now 9 rad 6 is the long leg of this 30, 60, 90. I need to divide it by radical 3 to get the short leg because I can only move around using the short leg. So I take the 9 rad 6 and I divide it by rad 3 and I get 9 rad 2 is the short leg. And then I need to multiply that by 2 to get x because the hypotenuse is double the short leg. Okay, awesome. Now we go to geometric mean. Find the geometric mean of 5 and 15. So that's 5 over x equals x over 15. And I get x squared equals 75. Square root both sides. 75 is 25 and 3, 5 and 5. So I get that x equals 5 rad 3. Now on this one, the geometric mean of 24 and what number is 144? So look, it's saying that the geometric mean is 144 if you kind of take out that middle part. So that means that 144 is x in my proportion. It needs to go like that. And then I just need 24 to go somewhere. And then I can find the other number. I'll call it b so we don't get confused with x's. So now we get 24b equals 144 times 144. And that is 20,736. And then I'll divide this by 24. And that's 864. And that's the answer there. Okay. Oh no, you couldn't see, but that was just a little bit of algebra you couldn't see. So cross multiplied, I got this, divided by 24, and I got that. Okay, now we've got to classify these triangles. So first, I double check if it is a triangle. I add the two smaller sides, 11 and 15 is more than 19. So I am good to go there. And then I circle the biggest side and take it over to c squared. and then I'm testing it to see if what the relationship is to a squared and b squared. So 19 squared, 11 squared, 15 squared. Are you guys leaving? Okay, no. And then I get, here we go. 19 squared is 361. And then 11 squared plus 15 squared is 346. And so this side is greater than, which makes number 13 obtuse. Okay, let's do 15 over here. So 7 plus 4 is 11. That is not greater than 11. This guy is not a triangle. Okay. Over here, 4.1 plus 5.5 is 9.6, and that is greater than 8. 8's going to be my hypotenuse, or my longest side, and I'm going to go 8 squared equals c squared equals a squared plus b squared. 8 squared equals 4.1 squared plus 5.5 squared. So 8 squared is 64. 4.1 squared plus 5.5 squared is 47.06. And I have been putting equal signs, but really we're checking greater than or and things like that. So this turns out to be greater than again. So this is obtuse also. I don't think I meant to not give you guys an acute angle, but that's okay. If it were less than, it would be acute. So just keep that in mind. And then over here, 14, 48, and 50. 14 plus 48 is definitely bigger than 50. I'll take the 50 and I'll go c squared, a squared, plus b squared. So 50 squared, 14 squared, 48 squared. Okay, 50 squared is 2,500. And then 14 squared plus 48 squared is, believe it or not, 2,500. This is an equal to relationship, and this one, 16, is right. Now, because it's a right triangle, and only when it's a right triangle do I even think about Pythagorean triples. Pythagorean triples, only right triangles, okay? In this case, all these numbers are integers, so this is a Pythagorean triple. Alrighty, guys. Best of luck.